Welcome back to yet another video of trigonometric ratios. So, we will make maybe one or two more videos on solving a few trigonometric ratios problems. And once we do that, then, as a progression, we'll move to the application based questions, which involves calculations of heights, distances, etc. Okay. So, uh, so last video we did examples where, we were given cos theta or cos value of certain triangles, and we had to find the rest of the other uh, ratios. So now we'll move to little tricky questions. When they are not tricky per se, but yeah, when they are a little different from what we have done so far. Okay, so this color is fine. So question is, if secant of alpha, if secant alpha is equal to 5 by 4, then evaluate 1 minus tangent alpha over 1 plus tangent alpha. Now, before I start solving these questions, so a couple of points I would like to make. Look, when you talk about trigonometry, or for that purpose, when we are going to move to different other topics as well in higher classes, you'll find a lot of concepts are interrelated. So maybe in past you would have studied how to solve linear equations, how to solve quadratic equations, or general mathematical operations, things like a plus b whole square, formulas like a plus b whole square, a minus b whole square. But we did apply in the last video a cube, a plus b whole cube, compound into dividend. You will see we are going to apply everything when we are going to solve trigonometric problems. Okay. Now, so there are multiple ways wherein you can start this question. Okay. One is that, from secant of alpha, you can convert into cos of alpha, and then, put that the same, the ratio of sides. You can calculate from there, or you can pick up the inverse ratios from the right triangle and, evaluate and then find the sides. At least two sides are given here, and then, you can find the third side. You can do so. That is one way of doing it. Other way of doing it is that you can simplify this expression, you know to large extent, so that you do not have to calculate the tan value, etc. So there are multiple ways you can look at it. So what we're going to do is that we are going to do it the first way, whereby we'll first find all the three sides, the value of all the three sides, and we'll find the value of tan alpha. Once we find the value of tan alpha, we'll put that value in this expression. First thing first, let's uh, draw a right triangle. It's always a good idea to use a tool so that at least triangle looks pretty neat and clean. Yeah. Oh, it's gone. Cool. So let's put it the side A. This vertex is A. This is B, and this is C. Now, what is secant alpha? Secant alpha is nothing but 1 over cos alpha. But what is cos alpha in terms of ratios? cos alpha is equal to base over hypotenuse, which makes secant of alpha as hypotenuse of over base. Now, what is the value of secant of alpha given to us? Which is, it is equal to 5 by 4, which makes our base as 4 and hypotenuse as 5. You know, the moment you get hypotenuse as 5 and base as 4, it's much evident that what is going to be the value of perpendicular. But anyways, we'll find it out. So applying the Pythagoras theorem, which makes BC square is equal to sum of squares of both sides. What are the both sides? AB square plus AC square. Now the value of AB is given to us, which is 4. It becomes square of 4 plus, this is what you have to find, AC square. And what is BC square? It is square of 5, which makes it equal to 25 is equal to 16 plus AC square. Now look pretty clear, right? What is going to be the value of AC? Let's do the same color. So this implies you just change the sides, okay? It's always good idea to have, whatever you have to find the value on the left hand side. AC square is equal to 25 minus 16. Hope you guys have understood what I've done, but anyway, for someone who would have not understood, I'll just tell. What I've done is that we have taken this side and switched it over here, and we have put the whatever was left on the left hand side, we have just moved to right hand side, so that our variable part comes on the left hand side. That's one. Second thing is that what we have done is that once we have taken 16 plus AC square on the left side, what we have done is that we have moved 16 on the right hand side, so that variable is on one side and the constant values are on the other side. Now this implies AC square is equal to 9. And what we are going to do now? Taking square roots on both sides. I've told you earlier, whenever we have got an equation, any mathematical operation we do on the left hand side and same operation we do on the right hand side, the equation remains unchanged. Meaning, if we add something to the left hand side and we add same thing on the right hand side, the equation remains unchanged. Similarly, if in case we divide any side, left hand side by a value, and then we divide the right hand side by the same value, the equation will remain unchanged. Similarly, if in case we are going to square up on the both sides, or maybe taking square root on the both sides, the equation will remain unchanged. So this means AC is equal to 3. So this is 3. So now we have got all the values in front of us. So what next we'll do? What we have to find is 1 minus tan alpha and 1 plus tan alpha. So simple, we have to find the value of tangent of alpha. So what is tangent of alpha? Okay. Tangent. What is the tangent ratio? It is perpendicular over base. And what's our perpendicular here? Is equal to 3 by 4. So this is the value of our tangent alpha. So what we have to do is that we have to put the value in the expression which we have been given in the question. So what is the expression which we are given? That is, now given expression is 1 minus tangent of alpha divided by 1 plus tangent of alpha. Let's mark it 1. And what next we'll do is that substitute. Yeah, you in exam or while solving this question, you do not really have to write all these things, you know. But of course, in case you have got time, you can always write it. But here I'm specifically writing so that whosoever is watching video, he gets complete clarity at what we are exactly wanting to do. Substitute value of tangent alpha in equation 1. So 1 minus tangent alpha over 1 plus tangent alpha becomes equal to 1 minus 3 by 4, and denominator is let's create some space here. Cool. It is 1 minus 3 by 4, and this whole gets divided by 1 plus 3 by 4, and it's pretty easy to solve from here. This is equal to 4 comes the LCM, it becomes 4 minus 3 whole divided by 4 becomes LCM, so 4 comes in numerator here, plus 3 divided by 4. Let's make it a little clean. Yeah, that's better. And this is equal to, I mean, of course you can write in multiple steps, but I'm just writing in one horizontal line just because of the space constraint. Anyways, it is 4 minus 3 over 4. We can write it like this, divided by 4 plus 3 over 4, and this equals to 4 minus 3 is what? It is 1 divided by 4 into 4. What we do is that we just, since we are changing the division to multiplication, we have just taken the reciprocal of this part, divided by, and what is 4 plus 3? 7. So 4 cancels with 4, and the answer is 1 over 7. So the value of the expression which was asked in the question is 1 by 7. So there was no trick here. It was a pretty straightforward question. But as I said, it was a little different question from what we have attempted earlier. Now, if you remember in the past video and in this video as well, what we did something for which a question should arise. We were given the value of secant of alpha, and that was 5 by 4. So we assumed hypotenuse is 5 and base is 4. But I mean, it's a ratio, right? So the values could be maybe 10 over 8. Yeah, when the length, the hypotenuse is 10 centimeter and the base is 8 centimeter. What does it mean? It means that as long as the ratios of our sides are same, the value of angle will not change. So, or you can say maybe the converse side, for the same angle, the trigonometric ratios will remain same. One is that it is looking pretty evident here, but then there's a small little proof in which we are going to use a geometrical concept of similarity of triangles. So I guess it's the right time that I take that concept also. So let's derive a theorem for you. So theorem. Look, we are not going to use it much. It's more from the understanding perspective, because a lot of people, till later in the class also, they are always confused that why we have taken this as base and this perpendicular, the value could have been different. So just for those people, I want to show the proof of this theorem so that they are very clear in their mind. So what is our theorem? We'll write it again and write in a different color. Let's take white. Theorem. Okay. What it says that the trigonometric ratios are same for the same angle. Okay. So what does it mean is that if sine of theta is 5 by 8, so there is a, okay, and then we make 5 by 8 as maybe 10 by 16, the value of sine theta will still remain the same. So what we are going to do here is we are going to use the concept of similarity of triangle here. So let's first make a triangle. Okay. So let's say it is O, P, Q. Now, what is given to us is that this angle is theta. Now, what you do is that you take some point here, say R, and drop a perpendicular. It's better. Drop a perpendicular S, RS on OP. Now, this is a right angle triangle, so this angle is 90 degree. Here we have dropped a perpendicular, so this angle is 90 degree. So what is happening here is these two lines are perpendicular. Sorry, these two perpendiculars are parallel to each other. So if these two lines are parallel to each other and this is the transversal, then these angles are corresponding angles. These angles. So this theta angle is common. So it's same in both the triangles. So I'm talking about triangle O, P, Q and triangle O, S, R. Now here, angle O is common, right? Angle angle S is equal to angle P and is equal to 90 degree. Third, angle R is equal to angle Q. So what does it mean? If you have done similarity of triangles before, it means triangle OPQ and triangle OSR are similar triangles. Similar triangles by triple A rule. Angle, angle, angle. So what similarity of triangles the triple A rule says is that if in two triangles all the three angles are equal, all the corresponding three angles are equal, then the triangles are similar. And what is the property of similar triangles? Is the ratio of the corresponding sides is equal, which means OR over OQ is equal to corresponding sides we have to take, okay? RS over QP. So this OR, so there are two triangles. One is this small triangle, one is this larger triangle. So OR is the hypotenuse of a small triangle and OQ is the hypotenuse of a bigger triangle. Similarly, RS is the perpendicular of the smaller triangle and QP is the perpendicular of the bigger triangle. And the third side, the base here is OS over OP. So this is the similarity rule. Now, say what is sine of theta? Sine of theta in this triangle is perpendicular over hypotenuse. Sine of theta in triangle ORS. And sine of theta in the is equal to QP over hypotenuse. What is hypotenuse? OQ in triangle OPQ. Now what we do is that from this equation number 1, what values we have? We have RS, OR, QP, OQ. RS, OR, QP, OQ. So we take this part. We say that from equation 1, OR over OQ is equal to RS over QP. Now what we do is that we cross multiply. Means we take QP here and bring OR here. We can do that, right? So it becomes QP over OQ is equal to RS over OR. So this is our equation number 2. Now, what we do that is that let's mark it as equation number 3 here, and jointly let's mark it as 2. Now you see, the value of sine theta here is RS over OR. But RS over OR is equal to QP over OQ, right? So it means this is nothing but QP over OQ. And QP over OQ is what? The value of this sine theta. It means that the trigonometric ratios are same for the same angle. In a sense, this point, the point R, this point, the position of this point, or the position of this point is irrelevant. So we could have had it here, we could have had it here, we could have extended both the sides and then drawn it here. Still the value of sine theta would have remained same, or for that matter the value of all the trigonometric ratios would have remained same. So this brings us to the end of this video, where we have solved one question and proved a theorem, and we'll do maybe 2 more videos to solve few more problems, and then we'll move to our next topic, heights and distances. Thank you.